Okay, question number 2. A potential difference of 8 volt, so V is 8 volt, is supplied across a 20 degrees Celsius iron wire, and then it has an area of 0.08 millimeters square, so that is 3 times 2, negative 6 meters square, and then given is the length of the wire, which is 0.5 meter, and the coefficient of resistivity is 0.005 per degree Celsius. Okay, so that is, we also have the current, which is 1.2 ampere lah. So now we have to determine the resistivity of the iron wire if the electric current flowing through the metal wire is 1.2 ampere. So actually, this value of I is for A lah. So the current is 1.2 ampere. We have to determine resistivity, where the formula is RA over L. However, we do not have the value of resistor, but remember we have Ohm's law. So from here we know that R is equal to V over I. Okay, so from here we can just substitute into the formula and we will get this equation here. So you just have to substitute 8 1.2. This is 0.08 times 10 to the power of negative 6. Divide by the length, which is equal to 0.5 meter. Okay, so from here you will then get the resistivity of the wire to be equal to 1.07. So this is 0.7 times 10 to the power of negative 6 ohm meter. Okay, alright, so that is question A. Question B pula, dia cakap after leaving the circuit closed for an hour, it was found that the electric current decreases by 0.01 ampere. So the final current decreases by 0.01 ampere. So this is the after the switch kena close lah, after the circuit is turned off, the current reduced to 1.199 ampere. Okay, so now we have to determine the change in the temperature of the iron wire. So this one we are gonna use the equation R equal to R naught 1 plus alpha T minus T naught. Okay, so since we have to find delta T, we can write this equation as this one here lah. Okay, so what is R? R, again, we can use Ohm's law, so it is just V over I. So we can substitute di sini lah, V over I. So I di sini adalah yang final, this one adalah yang initial. V tu dia constant lah. Okay, so sekarang ni kita ada 1 plus alpha delta T. So di sini kita just perlu substitute all the values. So we have 8 divided by 1.199 equal to 8 divided by 1.2, 1 plus 0.005 delta T. Okay, so what I'm gonna do is this one is gonna be here. So you will get 6 point, if I'm not mistaken, it's gonna be 6.672 divided by 6.667. But let me just double check if I'm correct. 6.672, yes. 8 divided by 1.2 is 6.667. Okay, so we have this, and this is gonna be the equation. So I'm gonna leave this value here as positive. So it's gonna be 6.672 over 6.667 minus 1. So it's gonna be delta T equal to, let me just check, because, so it's gonna be 8.34 times 10 negative 4 divided by 0.05. So you should get 0.167 Kelvin lah. Okay, okay, so you should get 0.1668, but I've rounded off to 3 decimal points, so it is 0.167 Kelvin lah. Okay, alright, so yeah, that is basically our solution for question number 2.